In order to find the inverse of a function, we're going to switch the domain and range, or in other words, the x and y in a function. So for example, let's take a look at this function right here. Now, I want to literally just switch x and y, and you may say, well, there's no y in the problem. But remember, f of x is just a fancy way to write the y. So I can rewrite that function as y equals 3x minus 5. So to find my inverse, like I said, I'm literally going to just switch my input and my output, my x and my y. So I'll start with writing x equals 3y minus 5. Now that is the inverse function. However, we always want our functions to start with y equals. So now that I've switched x and y, I'll still need to solve my new equation for y, just like we've done in the past. So start with any addition or subtraction in order to get y alone. So I'll add 5 to both sides. Now I can't do anything with that, so I'll just write x plus 5 equals 3 times y, just like we did way back when we were rearranging linear equations. And then to finish this particular example, I'll divide everything by 3. And what I'd recommend is, as I'm showing, divide every individual piece by 3. When I do this, I'll get y equals, I'll put that in the front, x divided by 3, or x over 3, plus 5/3 can't be simplified, so I'll just leave that as 5/3. And that is going to be my inverse function. Now you may have seen off to the side here this notation. It's nothing fancy. F is not a variable. I'm not going to try to change that negative exponent into a positive by moving this to the bottom of a fraction like we've done in the past. This is just a fancy notation, a fancy way of saying the inverse function. So instead of writing y equals, if I wanted to be really fancy, I suppose, I could rewrite this as the inverse function of x is equal to the same thing. Now just a couple notes just to clarify some things. Some of you may see this as an answer. That means the exact same thing. I can just slide the x to the side. So that would be fine as well. Also, if you didn't take my advice and just divided an entire side by 3, you may have this as an answer, which would be totally fine as well. All of those mean the same thing. They're all my inverse function. Okay, let's go ahead and take a look at a couple more examples where we're dealing with powers and not just a linear equation. We'll find our inverse function the same way we just did by switching x and y and then solving for y. Now the first part of this question asks us whether the inverse is a function or not. We'll take a look at how to answer that question in a different video. Let's stick with just finding the inverse for this video. So once again, I'm going to switch x and y. And remember, f of x is just a fancy looking y. So if I switch, I'm going to get x equals 2y to the third plus 1. Now that is the inverse function, but I want it solved for y. So since we're solving, we're going to follow the reverse order of operations. So we'll start with anything adding or subtracting. So I'm going to subtract that 1. Then we'll move on and get rid of anything that's being multiplied or divided. And finally, we'll finish with any exponents or radicals we need to do. So my second step is going to be to divide. And in this case, I'm actually going to break my advice from the last example and just divide the entire side by 2. Now you could still, like I showed you previously, divide each individual piece by 2. But for these, I don't know why, I just like to break that rule. So I'm going to switch around the order 2 and put the y cubed in front and then have this fraction x minus 1 divided by 2. My final step is going to be getting rid of that third power. Well, the opposite of raising something to the third power, or the inverse, is to do a cube root of both sides. So I'll do a cube root of that entire fraction. Make sure your fraction line includes that 2 on the bottom. Cubing a third root cancels that out, so I'm left with y equals the cube roots, and again, make sure that goes around the entire fraction, of x minus 1 divided by 2. So there's my inverse function, and it kind of makes sense that it would work out this way. Take a look. Our original function had a plus 1 in it, so it makes sense that my inverse has a minus 1 in it. They're opposites. My original function had me multiplying by 2. My inverse function has me dividing by 2. Again, they're inverses. And then finally, I had a third power. My inverse has a third root, so it kind of makes sense. Okay? If you think you got it, why don't you go ahead and pause the video and try that last example by yourself. Otherwise, let it play through, and my work will pop up real quick so you can check your answer against mine. So there's my inverse function, y equals the fourth root of x plus 9.